Section 6.5, factoring special products. So these are going to be special cases, and there's 3 that we're going to focus on. We will talk about the other one, but I'm just going to introduce that one. That one will not be on the test. I'll tell you which one when we get there. But the first one is probably the most important in my opinion. It's called the difference of squares, and we can recognize the difference of squares because when we try to factor it, notice there's only 2 terms. It's not a trinomial like we have been doing. There's only 2 terms. It's a binomial. Okay? And when we factor the difference of squares, what happens is it always ends up to be these 2 factors that are exactly the same, except for the middle sign is different. It's the only difference between the 2 factors. Okay?
Wouldn't that be A?
What do you mean? Okay, well, let's go through it and then you'll see. So the idea here, in order to recognize this pattern, this is what we're trying to factor. So there's only 2 terms, and each of the terms has to be a perfect square. Okay, so you have, and that's what I usually do first is I'll say, can we write it as a perfect square? If not, we can't use this pattern. Okay, so let's take a look at how we do it using the pattern. And then I will show you, if you don't like the pattern, I will show you how to do it with what we've already been doing the last hour or so. Okay, so here is the one that we're going to factor, and here is how I would suggest doing it. I mean, this one's pretty clear that it's x squared. But what is this one? What squared is 16?
4.
4 squared is 16. Okay. So then we can see it's following this pattern. You got something squared minus something else squared, right? And if you recognize that this is this pattern, all you do is write down x plus 4 and x minus 4, and that's it. You're done. But you have to recognize the pattern. Okay. Now, I want to show you, in case you're like, I don't know if I can remember that pattern, because it's not a pattern I'm not gonna put these patterns on the test because I don't want to confuse you by throwing extra stuff on there.
Oh, you're so kind.
Yeah. But if you don't like that method, I think this is a pretty easy one to learn.
Can I make an accordion?
An accordion?
You know what that means, right?
No. Is this a learning thing?
No, it's just
you mean
you put your answers on the piece of paper.
Oh, you're gonna cheat?
Kind of.
Okay. So here's the deal. If we tried to do what we were doing before, do you notice that this is really x squared plus 0x minus 16? We don't have a middle term, right? So we don't write it, but if we had to write it, it would be a 0. And so using the method we have been doing, we would take 1 times negative 16, which is negative 16, right?
We write it down.
If you want to, but again, this is if you're not going to use the pattern and if you're going to do it the way we have been doing these last bunch. Then what does, this is maybe a good one for you, what does this negative tell us about the signs of the numbers that we're looking for?
Different.
One is positive, one's negative. Now this is where it gets a little crazy. What does this tell us? It tells us neither of them are bigger because when you add them together, they cancel out, right?
The same number.
So it tells you they're going to be the same number. Does that make sense? So if they're both the same and you look at this 16, you're hopefully going to realize, oh, it's going to be a positive 4 and a negative 4. Because those are the numbers that are the same number but would cancel each other out. They add up to be 0, but they multiply to be negative 16. They have different signs. And then you would do the same thing that we've done before. So you would do x squared plus 4x minus 16. So you get your 4 terms. Factor by grouping. What can we take out of the first group? That was actually a question.
I'm still writing.
Oh, that's okay.
I'm thinking.
That's fine. Thinking and writing. We can take out an x. And what's left?
X plus 4.
And then we have to take out the negative. And what else can we factor out?
4.
4. And when we divide out the negative 4, what will we have left inside the parentheses?
1.
1x, right? Because you're dividing by, and then plus 4. So notice you get x plus 4 as something we can factor out, and then what's left is x minus 4. So you can do it using the same method that we've done the last hour or so, but it's much easier if you can recognize the pattern. Okay? And again, that pattern is always, you'll need to be able to write it as something squared minus something else squared. If you're going to use this pattern, that's what it has to look like. Something squared minus something else squared. Okay? And in this case, you can do it because it's x squared minus 4 squared.
And then we have to write.
And then your answer is x plus 4, x minus 4. Okay? So again, this is nothing that you have to do. It just is, it's just letting you know that what we have learned already, like I said, you can use it all the time, and you can use it all the time on any of these quadratics. Let's take a look at another one. Now this one's a little bit bigger, so it's a little bit maybe trickier. But one thing that would kind of tip me off is, first of all, there's only 2 terms. That's kind of a hint. I should maybe look at the difference of squares. And the fact that it's minus, I should maybe look at the difference of squares, because difference means subtract. And so let's try it. Can we write this as something squared minus something else squared? Well, 9 is probably pretty easy. What squared is 9? 3. And then you've got an a, right? So 3a times 3a is 9a squared. And then we've got the minus sign. And then again, 25 is not too bad. What squared is 25? 5. And then you've got a b squared, so that b goes there. So yes, we can write it as something squared minus something else squared. And once we know that, we know it's going to be these 2 parentheses that are exactly the same except for the middle sign, right? And so when we write it down, we just put 3a and 5b, 3a, 5b. And that's how the pattern works. So if you can recognize, if you can recognize the pattern, it's going to make things pretty easy if you remember how to use it.
So that's the answer.
That's the answer. Okay, much easier than going through that process and having to do factoring by grouping. Because 9 times 25 is going to be like 225, and that's a lot of factors to go through. Okay, so again, special pattern. The way you can recognize it, it only has 2 terms, and they're both perfect squares. Are we okay to go on? A resounding yes. All right, good. Now looking at this one, notice there's only 2 terms. But right away, the second thing we have to check is we cannot use this pattern. Why not? Yeah, the pattern only works if it's a minus sign in the middle. If it's a plus sign, we can't do it.
Oh, that's important.
That's very important. If it's a plus sign, you cannot do it. In fact, I think it's on your notes here. Notice the sum of squares is prime. Cannot be factored. So if you ever see 2 terms but it's a plus in the middle, I mean, I would look for a greatest common factor, but that's it. There's nothing else you can do with it. If it's a quadratic. Okay. So perfect square minus another perfect square, that's the pattern we're looking at. If it's a perfect square plus a perfect square like this one, you still can't do anything. You just leave it alone. It's prime. Okay. Put a lot of these on, because then you just know it's prime.
Hold on.
What?
Okay, we'll just leave it alone.
Oh, just leave them
So
alone.
if it is like positive, is it prime?
If it's only two terms and it's positive and they're both perfect squares, the only thing you could possibly do is factor out a greatest common factor. That's it. That's the only thing you could possibly do. Because you can always factor out a greatest common factor if there is one.
So x squared plus 36 is prime.
Correct. And a lot of times people want to make it like x plus 6 and x plus 6 again. But if you multiply that back out, you don't get x squared plus 36. There's a middle term. It's a trinomial. Okay. Now these are the patterns for perfect squares. If you see something that looks like this or something that looks like this and fits this pattern, it will factor to be two factors that are actually the same. We're not going to mess with learning these patterns because what we have already done for the last hour will work for these. So there's no sense to try and memorize this pattern to try and do that. The difference of squares one is so fast and so easy, and it looks different than the rest. That's why I would suggest probably try to learn that one. But it's not worth trying to learn. If you really, really want to and you love memorizing math formulas, here you go for it. But I wouldn't suggest doing that. So here's what will happen though if we factor something that has this pattern. Okay, and I'm not even going to bother showing you the pattern. I'm just going to factor it. We're going to factor it together so you can see what happens, because this hasn't happened yet. But knowing what we know from the previous sections 6.3 and 6.4, what would we do first? Yeah, 1 times 9. And that is 9. And since 9 is positive, here, regardless of where you look, they're both going to be positive. What does that tell us about the signs of the numbers that we're looking for?
Both can be positive.
Or,
Both negative.
yes, tells us they're the same. Okay. Then, once we know they're the same, and we go over to this, and we know they are same sign and they add up to be -6, it tells us that they are both what? They're both negative. Right? If you know they're the same and you're adding them up and they get a negative answer, they both have to be negative. All right, so let's write down the factors of 9, and there aren't many, that are both negative. -1 and -9. Does that add up to be -6? No. -2 doesn't work, so it doesn't divide in evenly. So -3 and -3. Does that add up to be -6?
Yeah.
Yes, so that's the ones we're going to use. So x squared minus 3x minus 3x again plus 9. We are going to factor by grouping, just like we did before. And what can we factor out of the first pair? An x. You may have noticed it's pretty much always going to be an x, or maybe a number with an x in that first pair. What's left after we factor out the x?
X minus 3.
Correct. Now remember, we have to factor out the negative. And what else can we factor out of the second group?
3.
3. And what else is left? X minus 3. Correct. Right? So notice these two are the same. So one of our factors is x minus 3. What's the other factor?
X minus 3.
X minus 3. So this is what happens when you have that pattern. Now, did we do anything different with our factoring? No, it just turns out that both of the factors end up being the same. And that means if you go back and look at this pattern, it was this one right here where they both end up being the same with a minus sign in between. But we don't have to worry about that because we just factor it and we get our answer. But it's okay that these come out to be the same. That's not a problem. Okay? She's like, it's not a problem. It seems like a problem. Okay, we're going to do a couple of these. These are the ones that are not going to be on the test. I can't remember. It's been a long time since I made this assignment and picked the problems for it, but I'm guessing there's 1 or 2 on the assignment, but it will not be on the test. So if you get stuck on those in the assignment, I mean, do your best, but don't spend tons of time worrying about that. Okay. Is it on the assignment?
Yeah.
Okay. I thought there was like 1 or 2, probably 2. Okay. So these are two special patterns, but again, they're pretty easy to recognize. First of all, because again, there's only two terms. It's either going to be a cubed plus b cubed or a cubed minus b cubed. And then the second thing that helps you recognize them is they're cubed instead of squared. Everything else we've been doing pretty much is squared. So this is the one new thing. I'm going to introduce it, but again, it won't be on the tests. Okay? But this one we will use the pattern for. Okay, and the pattern, so keep highlight, put a star by these two just so you have it for your homework. But again, it's not going to be on the test. But we're going to go through and we're going to do a couple of these. So first one. And again, you want to look for hints. Here's a big hint right here. If you see a cube on your variable, chances are it's one of these two. I mean, you can look for a common factor, but do you see there's no common factor? Okay. So that means, let's see if we can write this as something cubed, and then this is a minus something else cubed. So it would be this pattern if we can do it. So what cubed gives you m cubed? This is the easy part, because it's just m cubed. Now here you're going to have to think a little bit more. Is there anything cubed that will equal 27? That means something times itself again.
3.
3. And these get big pretty fast, so you start with your small numbers, like 2 times 2 times 2 is 8. 3 times 3 is 9, times 3 is 27. Okay, you're already up to 27. So it is 3. Okay, so we have written it so that it looks like this pattern. Right? Something cubed minus something else cubed. And then we just are going to follow this pattern. So, in fact, I'm going to use different colors here just to emphasize. So, let's use red. And everywhere I see an A in my pattern, I'm going to put in an M. Does that make sense? Because first part here, the M matches up with the A. Okay, so I'm going to put in an M here. I'm going to put an M here, and it gets squared. I'm going to put an M here, and that's all the M's. I suppose I should put in my signs. Oh, this is a typo. Okay, on your paper, fix this. This should just be a minus sign. So on your paper, if it says plus, make that into a minus. It should be a minus sign. Okay, so then we're going to copy our signs down. That's a minus, that's a plus, that's another plus.
Minus, plus, plus.
Yeah, let me move that over a little bit. Okay. So is everybody okay with the signs and the M's going in place of all the A's? Then, what do you think we're going to put in place of all the B's?
3.
A 3. So everywhere there's a B, we're going to put in a 3. So 3, 3 squared. Okay, now we do want to simplify a little bit. So this first part, we never have to do anything. We just write down m minus 3. This m squared, that's fine. Plus, here we would write 3m, and here we would write 9. And so that's how that one factors. Okay. Did everybody get this fixed on their paper? I apologize. Typo. Proves I'm not perfect, right? Any of you thought I was? That has been shattered. Sorry. Burst your bubble. Okay. And I'll try and use colors so you can see really easily which one is the A and the B and stuff.
Wait. Okay, got it.
Got it? All right.
Plus, plus.
Okay, so let's go on to this one. Now this one looks a little trickier, but again, a big hint. When you see these 3s, that's a big hint that you're dealing with cubes, right? So let's see if we can write it as something cubed plus, because it's a plus sign, something else cubed. All right, Now, is it pretty obvious because it's p cubed, there should be a p in here? Does that make sense? Obviously, there's going to be a p that gets cubed. What about the number part, though? What number cubed equals 125? And like I said, they get big pretty fast. So it's not going to take you very long to get there. 5 cubed is 125. So this is going to be 5p in the first parentheses. And then, again, hopefully it's fairly clear that it should be r cubed, right? Because it's r cubed, the variable. And then what number cubed will give us an 8? 2. 2 times 2 times 2. Okay, so we have identified our two parts. I'm going to go ahead and deal with these. Do you see that this time it's the top one because it's plus in between the two? A cubed plus the b cubed. So we're dealing with this one. So I'm going to go with all this one, all the a's. Whoops, that's a b. Okay, so let's put this in. Let me put in the signs. So we're going to have small parentheses and big parentheses. The first one has a plus sign, and then we're going to have a minus and a plus. Right? So in place of all the a's, we're going to put in 5p. So this will be 5p. This will be 5p squared. And then this will be a 5p. So everywhere there's an a, we're putting in that 5p. What are we going to put in everywhere we see a b? Yeah, the 2r. So this will be a 2r. This will be a 2r. This will be a 2r squared. And again, we do want to simplify. This first part, we just write down 5p plus 2r. But then here's where we have to be careful. And this is where a lot of my high school students make mistakes. This means, if you think back to last unit, this means 5p times 5p. So what does that actually turn into? 25p squared. A lot of people just do 5p squared and they don't put the parentheses, so they don't ever square the 5. And we've got our minus sign. And then here we're multiplying these two together. So we would have 5 times 2 is 10. And then PR. And then plus. And then again, same thing here as over here. 2r times 2r is what? 4r squared. And that's your factoring there. The other thing I haven't mentioned yet is when you use these two patterns, you will never be able to factor this. I don't know if you remember with the last one, it looked maybe like something that we could have factored. The second part of the answer, it was x squared plus, I don't remember what it was, but it's on your last example. Those will always be prime. You won't be able to factor this. So if you use this pattern, you just do this and you stop. You don't have to worry about trying to factor what's over here. Okay. Even if it looks like something that you have factored in the past, you won't be able to factor it. It will be prime. Okay. So again, hint on these, look for those cubes. Am I okay to erase this one? All right. What do you think about this one? There's only two terms, right? So it looks like it's probably one of our special patterns. But it's not cubed. It's squared. So we might be thinking perfect square. But the problem is 2 is not a perfect square, and 72 is not a perfect square. And here's where it becomes important. Always look for that greatest common factor. what can we factor out of both of these terms? A 2, right? When we factor out a 2, then this becomes 36x squared minus 1. 36 is a perfect square, and 1 is a perfect square. So now we recognize, oh, this actually is the difference of squares pattern. It was just hidden by this 2. So again, we're going to put the 2 out here, and we're going to see if we can make it look like our pattern. And our pattern is something squared minus something else squared. Okay, and again, in the first one, hopefully it's clear that should be an x, because x is squared. And then what number squared will give us 36?
6.
6 squared is 36. And in this one, I don't think it should be tricky, but sometimes people don't like this one. What squared will give us a 1? 1. People are like, no, how can something squared be itself? It does happen sometimes. Not often, but sometimes. Okay, so once we've identified the pattern, if you go back to your notes and you see the pattern, a squared minus b squared is factored, and it's a plus b and a minus b. So again, if you want to do the same thing and think about the a's, what are we going to put in place of those a's? Yep. Now we still have to have the 2, but we're going to put in a 6x here. I should have written all the parentheses first. I'll put the 6x here too. I'll fit the parentheses around it. And then the first one is plus, the second one's minus. Again, the order there doesn't matter as long as one is plus and one is minus. And then what goes in place of the b's?
1.
The 1. So this will be a 1. That'll be a 1. And that's what's going in place of the b's. And then this one is done. You don't have to do any simplifying. It's just finished at that point.
Plus, minus.
Yeah, the difference of squares is really quick. So that's why if you can learn that one I think is worth learning. The other ones are going to be longer. But always look for that greatest common factor first. Okay. Are you okay to go on? And again, notice this one looks kind of messy, but let's look for a greatest common factor. Do you see a greatest common factor here?
3.
3, and what else?
1.
They all have a y. So let's see what's left. This will be 16x squared minus 8x plus 1. So once we take out the 3y, doesn't it look like what we were doing, like 20 examples of in the last page of notes that we were doing? So what should we do? 16 times 1 is 16. And this is a positive 16, just like this is a positive 1. What does that tell us about the signs of the numbers we're looking for if they multiply together to be a positive?
Same. Positive or negative?
Yeah, they're both positive or they're both negative. They are the same. Okay. Then we go over here, and what does this tell us? If they have to add up to be a negative 8. Nope. Remember, you already told me they're the same.
Okay.
So that's why we check that first.
Bigger one?
They're the same.
Minus 5.
So if they're the same, you can tell me the bigger one's negative, but that means they're both negative, right?
I quit.
Don't quit. You can do it. I know you can do it. Okay. So they're both negative. So that's why we do this first. If we know they're the same, then this tells you they're both negative. If we know they're different, then this tells you the bigger one's whatever.
Oh.
Okay. Does that make sense?
Yeah.
You're getting light bulbs, and then it flickers. Then you get a light bulb again. And then... Okay. You'll get it. I know you'll get it. Okay, so both negative, -1 and -16 doesn't work. -2, and -8. Closer, but doesn't work. 3 won't divide into 16. -4, -4. That's the winner, right? So then remember, we leave this 3y on the outside, and we're going to replace the -8x in the middle with a -4x and another -4x, and then +1. And then we factor by grouping. So I've got them grouped. I'm going to write down my 3y. I don't want to lose it. It's got to stay there. What can we factor out of the first group? 4x. Now what's left after we factor out the 4x?
3. No. Oh.
She's right. It's bedtime. I got to go to bed. 4 and x, right? Because you had x squared and you factored out one of the x's. And then we have a minus sign, and then 4x divided by 4x will be?
Negative.
It'll be -1. Okay. Then remember, we have to factor out the negative in this second group. What else can we factor out of the second group?
1.
Yeah, just a 1. There's nothing else. And when we divide out that -1, what will be left in the second group? We'll have a positive 4x, and then 1 divided by -1, -1. Okay, dividing out a -1 just changes the signs. So we've got our 3y. What can we take out of both of those groups then?
4x minus 1.
4x minus 1. And then what's left?
3y minus 1.
Nope, right here.
4x.
4x minus 1 again. That's one of those where it was that special pattern where they both end up being the same. The 3y, you factor that out, and it just hangs out in the front the whole rest of the problem. You don't touch it again.
That's your answer.
That's our answer. Another way you could write this, and this is like the pattern, you could write it as 3y and then 4x minus 1 squared, because that's what it means to square something, multiply it by itself. But I'm totally okay with you writing it that way, just as two separate factors. But you may see, like in the homework, they may show you the answer, because when your last turn is over and it pops up the answer, it may show it as squared. Okay, let's take a look at this one. Just died. Evidently it did die. All right, anyway. So what do we do on this one? What should we always do first? Check if there's a greatest common factor first, right? Do we see any greatest common factor here? Definitely a 4. Let's see if there's anything. Does 8 work for both of them? Yes, 8 will work. So let's try an 8. Anything else? How about the letters?
8 is no work, I think.
8 doesn't work?
Because 54.
Oh yeah, 54 doesn't go. 8 doesn't go into 54. So we got to stick with 4. Wait.
Yeah.
4 doesn't go into 54, so we can't use 4. So maybe we have to stick with 2. Well, let's see. Let's find out. So 2, and then they all have an a, and they all have a b squared. So that leaves us with 64 a cubed. All the b's are gone, and then plus 27 b cubed. Ooh, that's kind of a hint. What is that a hint telling us? Probably need to use the cubes, right? So again, this 2ab squared will just stay out here. Let's see if we can write this as something cubed plus something else cubed. So obviously we have an a here being cubed. Is there a number that we can cube and get 64?
Four.
It is 4. 4 times 4 times 4. And then we obviously, hopefully, can see there's a b there that's being cubed. What about a number that cubed, will equal 27? Yeah, we actually did that one earlier tonight, right? 3. Now I'm going to go ahead and write out the pattern again so that we've got it. This is, you see it's a cubed plus b cubed, the adding one. It's on your notes, so you can just look above there, but it's a plus b, a squared minus ab plus b squared. Okay, so if we go with all the a's in red, let me write down our parentheses and stuff. I need a plus sign here and a minus sign and a plus sign. All right. So what are we going to replace all the a's with? 4a, right? So 4a squared, and 4a. And what do we replace all the b's with?
3b.
Yeah, 3b goes here, goes here, and gets squared. Okay, now the one thing we do have to be careful of is we factored out this part, right? So I'm going to put my answer here, but I've got to put the 2ab squared. Remember this part we don't have to do anything with, just 4a plus 3b. But what did I mention is a very common mistake? What do we need to do? 4a times 4a is 16a squared. What do we get when we multiply those?
12ab.
12. 4 times 3 is 12. AB. And you just have the minus sign in front. And then the plus sign. And then again, that same mistake. 3b times 3b is what?
9b.
9b squared. So that whole thing would be our answer. Okay. Make sure you use your pattern on those when you see it's cubes. I don't expect you to know that. Use your notes now that they're fixed since I messed them up. Okay. Now, as far as your homework, I know there's a couple problems with the cubic stuff, but focus mostly on all the squared things because those are the ones that are going to be on the test. So there won't be any cubes on the test. If there is, I messed up and I'll take them off. I'll double check. Okay. So I know it was a lot. There was a lot of. I'm glad we did the factoring by grouping last week, so that we had already kind of had a seen that already. But just remember, really, everything from 6.3 and 6.4, which is all together in one assignment, you're doing the same steps every time. I mean, look for your greatest common factor first, and then you're just doing that. Multiply a times c, and then split up the middle terms. You have 4, and then factor by grouping. Okay? And really work on understanding those signs. I mean, you can do it by writing down every factor, positive and negative, and picking the right ones, but it takes so much longer because you're kind of writing everything down like 4 times.